calculation, you end up with the molality of the solution will be 0.368 moles per kilogram. So again, the calculation involved in here really isn't nothing, it's just dimensional analysis, nothing new here. As long as you know how to use conversion, how to identify the conversion factor, how to plug them in, then the calculation is easy, and the calculator will do it for you. Okay. Another type of question here is that we can ask you if you want to prepare a solution with 0.450 molality, and the total volume is 500 milliliter. And how many grams of ethanol do you have to put in there? You can calculate the molality there. Now, this particular calculation there, this particular question there, we assume you know the density of water is 1 gram per milliliter. So a 500 milliliter will be 500 gram, 500 gram will be 0.5 kilogram. All you need to do is to figure out how many grams that we need. Now remember that equation on the first slide there. We say, well, we need to know there are 4 quantities involved in here. Okay? So in this case, mass is involved. We are trying to figure out the mass. And what we know here is that the molality equals to 0.450. Okay? That's moles per kilogram, the unit there. And that should equal to the number of moles of the solution. Now we don't know how many moles we have here. So we don't know how many moles, we don't know how many grams. But we know number of moles divided by the kilogram of the solvent will give you this answer here. So we have 500 milliliter converted into 500 gram, and that's water. Okay, so 1 gram per milliliter and times 1 kilogram per 1,000 grams. So gram and gram, this is for the water part, and the denominator. Okay. On top, we need to figure out the number of moles. Well, you have X gram so if you don't know how many grams of ethanol that you need to measure out, assume it's X. X times the molar mass, 1 mole equivalent to 46 gram. In this case, gram and gram will cancel out. So basically, X is your unknown. You get the moles on there. And if you plug in the number correctly and calculate figuring out the X there, it's 10.4 grams. So you need to measure out 10.4 gram of ethanol, put it into 500 milliliter water, you get the concentration. And so these type of calculations are very much similar to the molarity calculation that we talked about in chapter 4. And you just have to know the definition in order to be able to answer these type of questions there. And again, since this particular topic is not going to be on the final exam, after the final exam, if you have some time there, make sure you go over these calculations there. And this is a topic that we need to cover in either General Chem 101 or General Chem 102. And I know on this campus here, we include this particular topic in Chem 101. Now, we do not test you. The American Chemical Society first term chemistry exam does not cover this particular topic. We don't talk about this topic in Chem 102. And those people who are taking Chem 102 later on this semester, in the summer, at the end of the Chem 102, you will be given another ACS test. Well, I can't say that for sure because that depends on the instructor there. The 2 instructors, they are going to decide in the summer whether or not they're going to use the ACS exam. But if they do choose to use ACS exam, then you will see topics related to the molality on that exam. So, I just remembered there's a conversation between me and the other 2 instructors because I was coordinating the Chem 102. So I told them in the regular semester we use ACS exam as a final exam, but in the summer, and it's their call. And if they decide to use it, well, then expect to see questions related to this particular topic and those people who are taking Chem 102. Okay. And another type of question here, we can give you a concentration in percentage. So we'll give him a percent concentration, and we can ask you to calculate the molality here. Now here's an example. If we ask you to figure out the molality of a 28% aqueous ammonia solution. Now, yesterday when we were talking about chapter 11 there, well actually it's chapter 12 there. when we're talking about in the first learning objective, when we say, when you see the word aqueous, that means the solvent is water. Okay, so you have 28% aqueous ammonia solution. What does that 28% mean? And we would assume in this case, and the question should say 28 by mass or 28 by volume, we would assume 28% by mass. So this means if you take 100 gram of the solution, and you would have 28 grams of ammonia, and you would have 72 grams of water. Okay, so that's what that 28% by mass means. So in this case, we can assume if you take 1,000 gram or kilogram of this particular solution, you would have 0.28 kilogram of ammonia, 0.72 kilogram of solvent, water. So here, based on that information, we can figure out the mass of the solvent. And we also know the mass of ammonia. Molar mass for ammonia is 17 grams per mole. So if you know the mass, and you know the molar mass, you can figure out the number of moles. Okay, so if you have, say, if you take 1,000 gram of the solution there, you would have 280 grams of NH3, ammonia dissolved in there. And then each mole is 17 grams. In dimensional analysis, gram cancels out. And then on the denominator, 0.72 kilogram of water. So this is assuming you have 1 kilogram of the solvent there, and 28% by mass will give you these information. And plug in the number correctly, and you do the calculation, and will give you roughly about 23 molar. So that's another type of calculation. Again, everything that we showed here has something to do with the definition. You got to know the definition, how to define the molality, and that's very important. Okay, and so that's our introduction for the measurement of the solution there. Now, why do we need that quantity here? Because the behavior of the solution varies compared to the behavior of pure solvent, and that difference in terms of the behavior of the solution versus the solvent has something to do with the molality. And that's the concentration. It has something to do, some of the properties there of the solution depends on the number of particles dissolved in the solution there. So this is this is the time that we need to look into the relative number of particles that are dissolved in the solution. So the next learning objective that we're going to get into here is that we need you to be able to describe what we call the colligative properties of solution, namely vapor pressure. How does the vapor pressure change when you compare a solution versus a pure solvent? How does the boiling point change? How does the freezing point change? What about the osmotic pressure? Those are the 4 properties that we want you to know. When you have a solution versus a pure solvent, and they're going to behave differently on those 4 different properties there. And also, these are the calculation, the equations that we want to introduce there. And there is a freezing point change. The freezing point of the solution, it will be different from the freezing point of the pure solvent. So we say there's a freezing point depression. The freezing point of the solution is lower, and boiling point elevation and boiling point of the solution is higher than the pure solvent there. We can actually quantify that change in temperature in terms of the freezing point and boiling point. That change in temperature is having a